Bismillahirrahmanirrahim. Assalamu alaikum. I am Professor Hassan and you are watching my channel Professor Hassan Hamayo. It is lecture number 3 for the topic of experimental design. In the last two lectures, we have discussed important basic concepts of experimental design, and in the last lecture, we discussed important and essential multiple choice questions for every written test of statistics. And today again I will discuss more important questions for the paper of statistics for PPSC, FPSC and KPPSC. Before starting today's vital lecture, I request everyone subscribe to my channel, like and share my channel, and click the bell icon for the notifications of the next important videos. Let's start. Question number 1 is an experimental design which does not involve any randomization process is known as it is systematic design. Dear students, when you apply the treatments whose effect we are going to check on the experimental unit randomly, it is randomization. When every treatment has an equal chance of being applied on the experimental unit, it is randomization. But if you are applying non-randomly, then it is called systematic design. Next is the principle used to estimate experimental error is it is replication. In the last lecture I told you that if you repeat your process, if you repeat your experiment, then it reduces the experimental error, and that is because of replication. Replication is the process of repeating your experiment. Next is experimental error is due to extraneous factors. If it is raining and it is coming on the crops and it is affecting the yield of the crop, whether it is wheat, rice, sugarcane or cotton, then rain is the extraneous factor. Next is to get an idea of the fertility conditions of a field, the method used is if you want to check, if you want to get the idea of the fertility conditions of the field on which you are going to apply your treatment, it is the method is used, that is uniformity trials, a very important one. Next is local control in experimental design is meant to A. Increase the efficiency of the design, yes. B. Reduce the experimental error, yes. C. To form homogeneous blocks, all are correct. What do we do in randomization? We apply the treatments randomly on the experimental units. What do we do in replication? We repeat our experiment, it reduces the experimental error. And what do we do in local control? When the population is, when the experimental unit is heterogeneous, when there is large variation in the on the fields, then we make its homogeneous groups, that is local control. Then we apply the treatments on the blocks, on every block. Next is local control helps to reduce the error variance. Next is local control helps in A. Reducing the experimental error, B. Homogeneity of the experimental units, C. Both A and B. Both A and B is the correct answer. It helps in reducing the experimental error and it helps in the homogeneity of the experimental units. As I told you, we make the homogeneous groups, they are homogeneous internally and they are not homogeneous externally. Between them there will be the variation, but in internally there is less variation in every block. Next is local control is absent in CR design. In CR design we have randomization, we have replication, but we have not local control. Local control is a feature of RCBD and Latin square design, a very important one. Next is in designing an experiment, blocking is used for what? It is used for reducing the variation. Next is randomization and replication are must for any design, a very important one. They are must for every design. Next, in order to reduce the experimental error, in order to reduce the experimental error, we use replication and local control. Local control and replication are used to reduce the experimental error. Next is A subject receiving a treatment in an experiment is called, a subject which is receiving the treatment, it is called experimental unit. Next is who developed the technique of analysis of variance? Fisher. Next is who introduced the concept of relative efficiency in design of experiment? Yates. Next is local control is used to control the error variance. The strata which are more uniform amongst themselves than the field as a whole known as block. It is called block. A process of assigning the treatments to various experimental units in a pure chance manner is, it is randomization. Next, the design based on randomization, replication and local control is RCBD. It can never ever be CRD. Next is the precision of an experiment is measured by, very important one, the reciprocal of the variance of the sample mean. Next, which one of the following is not a basic principle of experimental design? We know the principles are randomization, replication and local control. Confounding is the correct option. It is not the basic principle of experimental design. Next is CRD is based on the principles of randomization and replication. Next, when experimental material is limited and homogeneous, what design is used? CR design is used. The experimental design which provides maximum degree of freedom for the error is, it is completely randomized design. Next, a completely randomized design is also known as non-restrictional design. Next, to compare several treatments when the experimental units are homogeneous, the appropriate design is CRD. CRD can be used for, very important one, equal and unequal replications, but RCBD will be used for only equal replication. When there occurs a missing value in an experiment, treatment sum of squares has an upward bias. And keep in mind that if we have a missing value in CRD, it will be of no importance. It has importance in RCBD and Latin square design. Technique used for solving the problem of missing observations in design was firstly given by Yates. Next, missing observations in CRD are eliminated. They are removed. They have no importance. They have been ignored. Next is, in a completely randomized design with K treatments, the degree of freedom for between levels of factors is K minus 1. Next is, for the estimation of the error variance, maximum number of degrees of freedom given in CRD. Next is, when the calculated f is greater than f value at 5% level of significance only, the differences in treatments is considered significant. A very important one. Next is, in a randomized block design, the homogeneity should be there within blocks. In the internally in the blocks we have homogeneity. Next is, RCBD is preferred on CRD when experimental units are heterogeneous. When there is large variation in the experimental units, we prefer RCBD on CRD. Next is, RCBD has two-way classification. RCBD can be used with equal replication. Next is, RCBD is not suitable for large number of treatments. In RCBD design we have one restriction. In lattice square we have two restrictions, and in CRD we have no restriction. Dear students, must command on today's lecture, and inshallah in the next lecture I will discuss more important questions of the same topic, experimental design. Assalamu alaikum.